Sound waves.
By the end of this lesson, you should be able to describe sound waves, explain how the loudness of sound relates to its amplitude, explain how the pitch of sound relates to its frequency. Click the Start button and listen to the sounds produced. How are sounds produced? Look at the man's fingers plucking the guitar strings. When the strings are plucked, they vibrate and sound can be heard. When the man vibrates and sound can be heard. What can you conclude from these? Sound waves are produced by vibrations. Vibrating musical instruments are examples of sources of sound waves. This jar is filled with air. Click the switch to start the bell. Can you hear the sound of the electric bell? What happens if the air is removed? Click the vacuum pump to pump out the air from the jar. Can you still hear the sound of the electric bell? You cannot hear the sound of the electric bell even though the hammer is still striking the metal. Why? When air is removed from the jar, there are no particles left to transfer sound energy. Thus, no sound can be heard. Sound waves propagate through a medium. Sound waves cannot propagate through a vacuum. Sound waves can travel through solids, liquids, and gases. A tuning fork produces sound waves. The tuning fork has two prongs. When the prongs move to the right, they compress air particles together. This disturbance is then transmitted from one particle to the next particle through the air, with the result of a pulse of compression moving outwards. A reverse movement of the prongs gives rise to the pulse of rarefaction of the air. Sound waves are longitudinal waves. The wave particles oscillate in the direction parallel to the direction of propagation of the waves. Wavelength is measured from one compression to the next compression or from one rarefaction to the next rarefaction. Turn the knob to increase the volume. What can you say about the frequency of the waves produced? The waves displayed on the oscilloscope screen shows the same frequency even though the loudness of the sound is changed. What can you say about the amplitude of the waves produced? As the loudness of the sound increases, the amplitude of the waves also increases. The oscillation of air particles is bigger for louder sounds. This causes the amplitude of the waveform to be larger. Turn the knob to increase the pitch. What can you say about the amplitude of the waves produced? The waves displayed on the oscilloscope screen shows the same amplitude even though the pitch of the sound is changed. What can you say about the frequency of the waves produced? As the pitch of the sound increases, the frequency of the waves increases too. The oscillation of air particles is faster for higher pitch sounds. This causes the frequency to be higher. Explore the waveform of different musical instruments. Click on any musical instrument. The same note played on different musical instruments does not sound the same, and each sound produces a unique waveform. The sounds have different qualities. This combination of different qualities of sounds is called timbre.